Welcome to our comprehensive tutorial on debugging Hibernate applications. In this session, we will explore common issues encountered while using Hibernate, and I'll guide you through various debugging techniques to efficiently troubleshoot these problems. Before we dive into debugging, let's quickly recap what Hibernate is. Hibernate is a powerful ORM tool for Java that simplifies database interactions and allows developers to work with database entities in an object-oriented way. However, when things go wrong, it can be challenging to track down the source of the issue. First, we will set up a simple Hibernate application to use as our testing ground. Let's create a basic Maven project that connects to a database. Now that we have our project set up, you'll want to add the necessary dependencies for Hibernate and your database connector. Visit your pom.xml file and under dependencies, include the following dependencies. Next, we will configure Hibernate. Create a hibernate.cfg.xml file inside the src/main/resources directory. This file will hold our database connection parameters. Now, let's create a simple entity class. We'll call it user. Create a new class in src/main/java/com/example/hibernate named user.java. With our entity created, let's move to the application logic. Create a class named main.java in the same package to interact with Hibernate. Now let's run our application to see how Hibernate performs. If everything is set up correctly, you should see the user saved to your database without any issues. If your application encounters an error during this process, don't panic. This is where debugging comes into play. First, let's look at the console output. Enable Hibernate logging to see detailed messages by adding the following to your hibernate.cfg.xml. Rerun your application now. The console should display the SQL commands that Hibernate executes along with any potential issues. Remember, always keep an eye on the logs, as they provide crucial information. Now let's simulate a common scenario, a missing database column. Remove the email property from the user class temporarily and run the application again. You should see an exception indicating Hibernate was unable to map the entity correctly. To properly debug this issue, we can follow a systematic approach. First, check for console logs. They can guide you to the source of errors effectively. The stack trace will show the exact line that caused the issue. Next, you could leverage a debugger integrated within your IDE. Let's use IntelliJ IDEA as an example. Set a breakpoint at the line where the transaction is committed and start the debugger. You can inspect variable states to see how data is flowing through your application. Another tip is to ensure that your entity mappings are correctly configured. Review the annotations on your entity classes. If you're confused, remember that Hibernate expects the column names to match or be at least mapped correctly to the entity attributes. Let's simulate another common issue, a misconfiguration in hibernate.cfg.xml. Purposely introduce an incorrect property name. For instance, change the property name for hibernate.connection. URL to hibernate.connection.url incorrect. Run your application and observe what happens. Upon running this, you should see an error indicating that the driver could not be loaded. Such misconfigurations can easily lead to frustrating debugging sessions, so it's always good to perform basic checks on the configuration files. Next, let's discuss external tools that can aid in debugging Hibernate applications. One popular tool is Hibernate's built-in statistics. To enable this, add the following property in your configuration file. You can access these statistics in your Java code like this. This will provide valuable insights into your application's performance, helping you pinpoint areas that may need optimization. Let's now address lazy loading issues, which can be a source of headaches in Hibernate. If you try to access a lazy loaded collection outside of a session context, you may face lazy initialization exception. Here's an example of code that causes this error. To debug this, ensure that the session is open while accessing the data you need. One way to solve this is to use join fetch in your HQL queries, like so. Alternatively, consider using DTOs to fetch only the data you require, which can improve performance and reduce unnecessary queries. For a deeper dive into your SQL queries, you can enable SQL logging and parameter binding. In addition to hibernate.show_SQL, add the following to your configuration. This will allow you to see the actual SQL statements being generated, helping you identify any potential inefficiencies in your queries. Finally, let's cover some best practices to keep in mind while debugging Hibernate applications. Always make use of logging. It doesn't just help you debug, but also allows for performance insights. Regularly check your entity mappings and ensure they align with the database schema. Utilize tools like JPA Buddy or Hibernate Validator to ensure that your mappings are correct. Also, maintain a consistent transaction management strategy to avoid any unexpected exceptions during data operations. In conclusion, debugging Hibernate applications may seem daunting at first, but becoming familiar with the common issues and utilizing the debugging tools we discussed will significantly ease the process. Always remember to leverage logging, utilize IDE features like breakpoints, and carefully analyze your configurations. Thank you for watching. If you found this tutorial helpful, please like and subscribe for more programming tutorials. Don't hesitate to drop your questions in the comments. Until next time, happy coding!